Okay, good day guys, and welcome back. We will do more concept calculation today. All right, and we have a very interesting question here by my student. Okay, we have an experiment. They reacted 20 gram of zinc carbonate with excess dilute nitric acid. You are required to calculate the molar mass of your zinc carbonate. All right, your zinc carbonate. We have to calculate the molar mass, and part B, calculate the number of moles of zinc carbonate that has been used, because they give you 20 gram of zinc carbonate, and from there we are required to find the number of moles of zinc carbonate that has been used with respect to your 20 gram of zinc carbonate. And then of course we have to determine the number of moles of zinc nitrate produced. Zinc nitrate will be produced because our zinc carbonate here react with excess dilute nitric acid. Excess means we have more than enough. There will be balance, right, after the reaction is complete, because we have limited amount of zinc carbonate. Once zinc carbonate has completely react with your dilute nitric acid, there will be still excess dilute nitric acid. All right, so not to worry so much about the word excess here. And of course, part D, they say determine the mass of zinc nitrate produced. That means you have to find the moles and mass of zinc nitrate produced. All right, first let's do your part A. We are required to find the molar mass of your zinc carbonate. Yeah, first of course you must know what is the formula of zinc carbonate, right? Zinc, from your periodic table, zinc is your zinc 2 plus, yeah. Your carbonate is CO3 2 minus, right? This one you must memorize. Your zinc you can get from your periodic table, right? Zinc, if you look at periodic table, is your transition element 2 plus, okay. And from there, the formula, right, the chemical formula, just crisscross there, right? So 2 and 2, well, just nice. That means your zinc CO Zn CO3, that's it, right? Because the ratio is 2 is to 2, so balance off, simplified, right? Just like in your primary school, 1 is to 1, isn't it? Okay, so you have zinc carbonate, and you are required to find the molar mass. Okay, what's the difference between molar mass and the relative molecular mass? All right, basically the molar mass is the same thing, similar to your molar mass. Only that molar mass has unit. All right, your MR, relative molecular mass, of your zinc carbonate here does not have unit. So we just calculate the MR, right? MR means your zinc is 65, so equal to 65, right? Plus your carbon 12, and plus your oxygen here, of course, 16 times 3. Use the AR, please. Okay, so total up you get 125. And relative molecular mass, it does not have unit, but molar mass, okay. Since the word molar mass, it has mass, it has mole, okay, that's why it's molar mass. All right, so MR of 125, so the molar mass of your zinc carbonate, right, is 125 gram per mole. In other words, for every 1 mole of your zinc carbonate, it will have 125 gram with respect as far as zinc carbonate is concerned. All right, that's all about it. So the molar mass is 125 gram per mole. That's all. Okay, simple. Now next one is, they said in an experiment, of course, early reactor again, of course, 20 gram of zinc carbonate with excess dilute nitric acid. We are required to find the number of moles of zinc carbonate that has been used. So this question is good that we write down the what do you call that, the chemical equations. All right, the chemical equation is very important, so that we know what's going on, right? So you have your zinc carbonate, okay. All right, your zinc carbonate is a white powder, yeah, crystalline, okay. It's a metal carbonate, yeah, okay, it's solid. So plus your dilute nitric acid will be HNO3, right? HNO3, that will give you your aqueous. Of course, this one acid must be aqueous, because a little bit of property of acid Acid is where a substance dissolve in water and it will, what do you call it, ionize into hydrogen and NO3 minus, right? So as long as it give you H plus ions when dissolved in water, okay, please take note, it has to dissolve in water and it has to produce H plus ions, then we can call that particular substance as an acid. If not, it is not an acid. That's why for every acid, yeah, the state symbol must be AQ, aqueous. Aqueous means dissolve in water. If you do not put aqueous, your teacher will deduct some marks. Okay, so it's not worth it. And of course, you must know why it is aqueous, right? All right, the state symbol must include aqueous for acids only. And acid, we have H in front of it. It symbolizes the fact that when this HNO3 dissolve in water, it will produce H plus ions. That's why sometimes in my class when I teach acid, bases, and salts, I love to say that acid as I created a character of acid man, you know. So it's a kind of a Superman character, you know. So it will go jump into the swimming pool and it will become H plus ions and save the world, something like that, huh? Right? Your Marvel comics, isn't it? Okay. Next, what will these two substances produce? Remember, this is a metal carbonate. Okay, metal carbonate, and this is an acid. React with an acid. Okay, react with an acid. What will it produce? Now, some of your teachers may tell you that you have to memorize metal carbonate plus acid produces salts plus carbon dioxide plus water, right? If you were told to do so and if you have difficulty memorizing it, not to worry, because I don't feel the need to do that. You know why? Because when you have this zinc carbonate react with nitric acid, you have your metal zinc and your nitrate. So obviously you have your zinc and nitrate NO3. Now is this a formula for zinc nitrate? Obviously no, because your zinc is 2 plus, your nitrate is NO3 minus. So when you crisscross, you will get Zn. The 2 will go for your nitrate. So you have your NO3 bracket 2. Okay, this is your zinc nitrate. This is your salt. Okay, so do take note about that. So that is your salt. Okay, so you have to put bracket here 2. You must know why there's 2 there. And obviously it will be still in aqueous state. Right? How can it be not? Right? Because you have lots and lots of acid, excess dilute nitric acid. Obviously it will be in aqueous state. And what else will you be getting? Obviously you will have your carbonate here produces carbon dioxide, CO2, and obviously carbon dioxide must be gas. Okay, so gas, and then what else? Don't forget we have hydrogen. Oh, hydrogen says what happened to me? You cannot just leave it as it is, right? Okay, so we have H, and then H what? Is it hydrogen gas? No way, because carbon dioxide is CO2. This is CO3. So obviously there must be extra oxygen, right? So the extra oxygen will produce there. So you have your water. Obviously water in liquid state. That's all. Okay? Simple, right? And after that, once you have written this, you need to balance your chemical equation. Balancing is easy, right? Just take note what you have, right? And use it intelligently. All right, not to worry. Okay, it's not difficult. So that's why, again, if let's say your teacher tell you to memorize the word, metal carbonate plus acid, give you salt, carbon dioxide, and water. If you have any difficulty, you may just focus on the fact that, you know, write down any kind of metal carbonate, and any kind of acid, any acid for that matter, right? Plus any of your this um, metal carbonate, right? It can be sodium carbonate, it can be magnesium carbonate, right? Okay, and later maybe one of the days I will make another video about this, to explain to you not to really memorize those things that you don't like, right? Okay. Well, balancing, the fact that we have what? Zinc, no problem, right? Zinc, we have no problem. Carbon dioxide, carbon, we don't have problem. Oxygen, we have this. But then we have this little 2 there. We will have problem with nitrate, NO3, 2. So minus 2 here. If once you put there 2, 2 give you the hydrogen also, right? So H2. So beautiful, isn't it? Yep. Therefore, we are safe or balanced up already. Okay. In other words, what it means, and some students after balancing they do not know what it means. When you have nothing in front of the zinc carbonate, it means 1 mole of zinc carbonate react with 2 mole of nitric acid. The number 2 there, it means the number of moles. All right, 2 moles of nitric acid give out 1 mole of your this zinc nitrate, 1 mole of carbon dioxide, and 1 mole of water. All right, do take note of that. Okay, the numbers in front of your zinc nitrate is not for fun. All right. Okay, or for example, imagine, just imagine if there's a 3 here, it means 3 mole of zinc carbonate produces 4 mole, imagine, just example. All right, 4 mole of carbon dioxide and 5 moles of water, just example. All right, so the numbers in front of your chemical formulas, there's a meaning of it. It means the number of moles, right? So from there, can we calculate the number of moles of zinc carbonate that has been used? Zinc carbonate, where is our zinc carbonate? This is, right? So we need to know number of moles. Now we know that they use only 20 gram, right? And our molar mass, of our zinc carbonate, right, is 125 gram per mole. Correct? That means for every 1 mole, of zinc carbonate, right, it will be corresponding to 125 gram. Correct? 125 gram of zinc carbonate for every 1 mole, right? But obviously this experiment, Ali does not use 125. He only used 20 gram. Why must he keep on using 125? No point, correct? Yeah, right? It's just like cooking, right? Not every time you must use 1 kilogram of meat, whatever, and 1 liter. You will, according to your needs, correct? So he needs only 20 grams, so he just put 20 grams. Yeah. Okay, so from there, obviously this is a simple ratio, correct or not? It means 20 gram divided by 125 gram, okay, multiply 1 mole. Just a simple mole calculation. All right, so the gram and gram you can see clearly cancel off. 20 divided by 125, you will get 0.160 in 3 significant figure, and what unit will you have left is mole, so it has to be mole. You cannot go wrong. So 0.160 mole of zinc carbonate has been used. Okay, simple, very simple. All right, so next we have the next question. Determine the number of moles zinc nitrate produced. All right, determine the number of moles of zinc nitrate produced. Remember our formula? All right, your zinc carbonate, okay, solid, react with your 2 moles of HNO3. Okay, we have balanced the equation right just now. Okay, produces your salt. Yeah, your salt is your zinc nitrate. Nothing else can be, correct? Not? And nitrate is valency 1, so NO3 zinc is valency 2. That's why you have 2 there. All right, and obviously it's equal state plus your, what else can it be? Carbon dioxide, correct? Courtesy of carbonate there, and carbon dioxide must be gas, right? And of course we have hydrogen and extra oxygen here. Well, give them water, right? Water will also be produced. But this question, they just want us to find the number of moles of zinc nitrate. Okay, how many moles of zinc nitrate produced with respect to the 20 gram of zinc carbonate? All right, so remember I told you the fact that there are no numbers in front, it means it's 1 mole of zinc carbonate will be producing 1 mole of what? Of zinc nitrate, correct? NO3. Bracket 2, this is your zinc carbonate. Okay, your product and your reactants, right? The product is your zinc nitrate, your reactants is your zinc carbonate. So 1 mole each. 1 mole of zinc carbonate produces 1 mole of zinc nitrate. So obviously we know we have just calculated just now 0.160 mole of zinc carbonate will produce 1 mole of right. So 1 mole, so here also be 0.160 molar. Simple as that, right? Okay, write down the statement, huh? I'm too lazy to write. Okay, simple for your teacher to mark. Okay, I got no teacher to mark, so I don't have to write. Now, next is determine the mass of zinc nitrate produced. The mass. This is the mole of zinc nitrate, and we are required to find the mass of zinc nitrate. Okay, so we're gonna do simple, right? Back to our molar mass, the MR of zinc nitrate, right? We need to find ZnNO3 bracket 2, right? And MR. From the MR is similar to your molar mass, right? Yeah, molar mass means what? The mass per mole, right? Okay, how much gram per mole? That's your molar mass of your zinc nitrate that we're going to calculate from your MR, relative molecular mass. So AR of zinc, relative atomic mass of zinc is 65 plus your nitrogen is 14 plus your oxygen 16 times 3, NO3, right? Times 3, close bracket, then you have to time by 2. Why 2? Because of your little baby 2. Okay, so put that 2. All right, so total up you get 189. You see how fast I calculate? All right, I use calculator lah, huh? Anyway, so obviously this molar mass of your zinc nitrate will be 189 gram per mole. Correct or not? That's your molar mass. It means 1 mole will be giving you 199 gram of zinc nitrate. And we only have zinc nitrate just now we calculated already 0.160 mole. Correct or not? Therefore, 0.160 mole will be having a mass of, simple, right? You know it, right? It's just a simple 0.160 divided by 1 multiplied by 189 gram, right? So therefore the mass of your zinc nitrate NO3 bracket 2 will be equal to, you see, 0.160 mole. I purposely do this so that you can see easily done. Okay, divide by mole by the same unit, divide by the same unit, right? And of course multiply by 189 gram. All right, this is just a simple primary 4 ratio, right? I do not use any goodness, the formula, right? The triangle, everything in the triangle. If you want to memorize, you have to memorize about 20 or 30 of this funny looking triangle there, and it can kill, right? Mole and mole cancel off, simple calculation, you're left with gram. That's why it's mass, correct or not? Yeah, and once you do that, you have your 30.24 gram, done deal, of zinc nitrate that will be produced. That means this Ali good boy here, he will get 30.24 gram. Okay, this is theoretical answer. Yeah, of course, practically impossible for him to get, and that will be another part of our calculation, percentage purity, and so on and so forth, percentage composition. All right, next video. All right, thank you guys. Thank you for watching. Have a nice day. Bye. Take care.